Okay, so we can evaluate functions of angles that are bigger than 90, any size angle, just by knowing what quadrant that angle is in and what sign should be on that particular trig function. So we're going to find sine 240 by using that method. So if we start at 0 and we go 90, 180, and then we have to go all the way to 240. And so the question is, what is our reference angle? And that is just going to be 240 without that 180 right there. So 240 minus 180 is what that's going to be. So this angle is 240 minus 180, and that's 60 degrees. So we have this triangle with a 60-degree angle. And so what do we know about the sine of 60 degrees? Well, we looked at our 30, 60, 90 triangle. Remember, we started with an equilateral triangle. All the sides could be 4. And then if you split it down the middle, the top angle is bisected, 30 and 30. And the base of the triangle is split 2 and 2. And so you find out that the hypotenuse in a 30, 60, 90 triangle is twice as long as the short leg, the leg that's across from the 30-degree angle. And the long leg, remember, is just the short leg times the square root of 3. If we use the Pythagorean theorem, that's what we get. So the sine of a 60-degree angle is 2 square root of 3 over 4. So sine 60 is equal to 2 square root of 3, opposite, over hypotenuse, which is 4. So that's the square root of 3 over 2. So we know that the sine of 240 is going to be the square root of 3 over 2. We have to just make sure whether it's positive or negative. And in the third quadrant, remember, your sine is involved with this side of the triangle, opposite to the angle, your reference angle. That's the y coordinate. In the third quadrant, y is negative. And so sine is negative in the third quadrant. And so sine 240 is going to be negative square root of 3 over 2. It's square root of 3 over 2 because it's a 60-degree reference angle, and then it's negative because sine, cosine are both negative in the third quadrant. So we've got tangent negative 225 that we're going to rotate 225 degrees in the clockwise direction because of that negative sign. And so we're starting at 0, and we rotate around 180 plus a little bit more, and that's going to put us in the second quadrant. So we're going to draw the terminal side of our angle, and the angle between that terminal side and the x-axis, that is our reference angle. And so we want to figure out what that is. Well, we want 225 degrees, but we don't want all that 180 degrees of those two quadrants down there. We just want the piece that is after the 180. So 225 minus 180 is 45. So theta prime is 45. And so we've got our triangle there. And remember, 45, 45, 90 looks like this. So the two legs are the same, and that's why tangent 45 is 1, because it's opposite over adjacent. The tangent of negative 225 is the same as the tangent of 45 degrees, which is 1. However, in the second quadrant, tangent is negative. So the tangent of negative 225 is negative 1. Okay? You've got 11 pi over 6. 11 pi over 6 is almost 2 pi because it's 12 pi over 6 would be 2 pi. So you're going to be going all the way around the circle, except you're going to stop short pi over 6. So you can think 12 pi over 6 minus 11 pi over 6 is pi over 6. So the cosine of pi over 6, so pi over 6 is our reference angle. The cosine of pi over 6 is adjacent over hypotenuse, so square root of 3 over 2. And so the secant of pi over 6 is the reciprocal of that, 2 over the square root of 3, which, if you rationalize it, is 2 square root of 3 over 3. What's the sign on secant in the fourth quadrant? The cosine in quadrant 4 is positive, and therefore the answer is going to be positive 2 square root of 3 over 3 for the secant. Okay, secant 9 pi over 2. Okay, so before we can do the next problem, we're going to need to look at what are called the quadrantal angles. And those are the angles at 0 degrees, 90 degrees, 180, and 270. Anytime you have an angle whose terminal side is on one of those angles, you can't draw a triangle. What are you going to do? What we have to do for those is think about what the value of sine, cosine, tangent are approaching as you get closer and closer to those angles. Just like we did when we were talking about functions that had asymptotes. So what I have here is a circle. It's called the unit circle. We haven't done it yet. That's why I have to go over this even though it's not in your notes because we didn't do that yet. So this is called the unit circle, and it's just a circle with radius 1. And so if we look at this, as you're going around from 0 and you're heading up toward 90, you can see that the short side, the side that's adjacent to the reference angle, is getting tinier and smaller and smaller and smaller. You can see that the side that's across from the reference angle is getting bigger and closer to 1. Remember that sine and cosine are between -1 and +1 always, because sine is opposite over hypotenuse, and the opposite side is always smaller than the hypotenuse. So that means that sine is always a fraction with the numerator less than the denominator, so it's always between -1 and 1. If this is a circle of radius 1, the hypotenuse is just 1. So as you're going around 30, 45, 60, as you're getting closer and closer to 90, you can see that that opposite side of the triangle is getting closer and closer to 1. So as you're going, the sine function is getting closer and closer to 1 over 1. So that's why we say that sine 90 degrees is 1 and cosine 90 is 0, because you can see that adjacent side is getting tinier and tinier and tinier until it gets to 0. And then as you're going around, you can see that as you're getting closer and closer to 180, the x-coordinate is getting closer and closer to -1. So the adjacent side is getting closer and closer to -1, and the opposite side to the reference angle is getting closer and closer to 0. So when you get to 180, you're going to have sine is 0 and cosine is -1. So as you're moving down toward 270, you can see now the opposite side of the triangle is getting bigger and bigger, closer and closer to 1, actually -1. And the adjacent side, the x-coordinate, is getting tinier and tinier. Sine is -1 and cosine is 0. And then as you go back up to 0 degrees or 360, you can see that the opposite side is getting tinier and the adjacent side is getting bigger. So when you get to the top, cosine is now 1 and sine is 0. Tangent is opposite over adjacent. Opposite is very close to 0. Adjacent is close to 1. So as you get to 0 degrees or 360, you have a tangent that is going to be 0. Because, like I said, opposite side is very close to 0, so it's getting closer and closer to 0, so tangent is 0 right here. But when you're at 90 degrees, as you're getting closer and closer to 90, you can see the opposite side is approaching 1, and the adjacent side is approaching 0. Tangent is opposite over adjacent, which means that tangent, when you get up to the top, the denominator is going to be 0, and that's not okay. So the tangent is undefined at 90 degrees. So the bottom line on all that is that sine 0 is 0, cosine 0 is 1, tangent 0 is 0. That means that cosecant 0 is 1 over 0, the reciprocal of sine, so it's undefined. Secant 0 is 1 over 1, so it's 1. Cotangent 0 is 1 over 0, so it is undefined. And then you've got sine 90 is 1, cosine 90 is 0, and tangent 90 is 1 over 0, so it's undefined. Cosecant 90 is 1 over 1, so it's 1. Secant 90 is 1 over 0, it's the reciprocal of cosine, so it's undefined. And then cotangent of 90 is 0 over 1, so it is 0. Sine 180 is 0, cosine 180 is -1, tangent 180 is 0, so their reciprocals are going to look like this. And then for 270, sine 270 is -1, cosine 270 is 0, tangent 270 is undefined, and so the reciprocals of those will look like this. Okay, so you have secant of 9 pi over 2. First thing you got to do is figure out where that is, 9 pi over 2. Remember that all the way around, one time all the way around is 2 pi. So over here, 0, pi over 2, 2 pi over 2, which is pi, 3 pi over 2. All right, so 9 pi over 2. How many pi is that? I'm going to make it into a mixed number. So 2 goes into 9 4 times, so 4.5 pi. So 4 pi, that's 2 times around the circle. So 1 time, 2 times all the way around, and then another 1/2 pi or pi over 2, which is up here. First of all, secant pi over 2 is the same thing as 1 over cosine pi over 2. And we know that cosine pi over 2 is 0. And so secant pi over 2 is going to be the reciprocal of 0, which is undefined. So secant 9 pi over 2 is undefined. Part B, you've got negative 5, 10, so you're going to be going in the clockwise direction. Going to go all the way around one time, 360, and then how much more do you need to go? Well, we can say 510 minus 360 is going to be 150. So we need to go another 150 degrees in the clockwise direction. So that's going to be 90, and how much more? 90 plus what is going to give you 150? That's going to be 60. So that's 180 minus 150 is giving you that reference angle right there. So you've got a 30-degree angle, and so the sine of 30 is 1/2. So sine 30 is 1/2. But now we are in the third quadrant where both sine and cosine are negative. So sine negative 510 is equal to negative 1/2. So for this problem, we're going to draw a triangle. But the question is, which quadrant are we going to draw it in? Well, let's think. Where is sine negative and cosine positive? Well, sine is negative below the x-axis because whenever you're below the x-axis, your opposite side is negative. So sine, if you go back and look at where we talked about which quadrants the sine, cosine, tangent are positive and negative, the third and fourth quadrants are the quadrants where sine is negative. But we want cosine to be greater than 0, so we want it to be positive. And that happens in the fourth quadrant. So we're going to draw our triangle in the fourth quadrant. We know that the angle here is theta, and we know that sine is opposite over hypotenuse, so opposite is 4, and hypotenuse is 7. And to find out what the adjacent side of this triangle is, we're going to say x squared plus 4 squared is equal to 7 squared. So x squared is equal to 49 minus 16. And so that is going to be 33. So the square root of 33 is that side. And so that's our triangle. And the question is, find cosine theta and tangent theta. So when we do that, cosine theta is going to be positive. It's going to be adjacent over hypotenuse. So square root of 33 over 7. And then tangent theta is going to be opposite over adjacent. And so that's going to be 4 over the square root of 33. But I forgot to mention that 4, that's in the fourth quadrant, that vertical side is negative. So we have to put a negative sign wherever we see a 4. So that's got to be negative. But we also have to rationalize it. So that's going to be negative 4 square root of 33 over 33 for the tangent of theta, because tangent is negative in the fourth quadrant. Okay, example 6, given cosine theta is equal to negative 3/5 for theta in quadrant 2, find sine theta and tangent theta. First, solve using an identity. First of all, I think in your notes this says quadrant 3, but in the book it says we're in quadrant 2, but we're not going to draw this. First it says to do it with an identity. And if we've got cosine and we're looking for sine and tangent, we're going to need our Pythagorean identities. So far, those are the only identities we have that will let us get sine and tangent from cosine when we don't know the angle. So we don't know the angle. We don't even have to find the angle. We're just going to use the Pythagorean identities. And remember, the first one is sine squared theta plus cosine squared theta is equal to 1. Then I told you that if you divide this by sine squared, you can get the second identity. And I don't know if I mentioned that the notation sine squared theta, all it means is sine theta squared. They chose to do that notation because that way you don't have to write parentheses every time. Okay, so if you divide that first identity by sine squared theta, you just get 1 plus cosine squared over sine squared is cotangent squared theta, and then 1 over sine squared theta is cosecant squared theta. And then if you had divided that first identity by cosine, you would get sine squared over cosine squared is tangent squared theta, and then cosine over cosine is 1, and then 1 over cosine squared is secant squared theta. So actually, you're just going to need the first identity and the third identity to do this problem because you have cosine and you're looking for sine and tangent. So first thing we know is that cosine theta is negative 3/5. We know that in the second quadrant, sine is positive. So we know whatever we get, it needs to be positive. So we'll just do this identity. We'll put sine squared theta plus cosine squared. Cosine is negative 3/5. I'm going to square that, and that's supposed to equal 1. So sine squared theta plus 9/25 is equal to 1. Sine squared theta is equal to 25 over 25 minus 9 over 25. So sine squared theta is equal to 16/25. And so sine theta would be plus or minus 4/5. But we know it's the second quadrant, so we know that sine is positive in the second quadrant. Okay, to find tangent, I'm going to use the third identity right here. So tangent squared theta plus 1 is equal to secant squared theta. Well, we've got that cosine theta is negative 3/5. So secant theta is the reciprocal of cosine. So negative 5/3. So this is going to be negative 5/3 squared. So tangent squared theta, I'm going to subtract 1 on both sides. So negative 1 plus 25/9. So tangent squared theta is plus or minus 4/3. But we know that in the second quadrant, tangent is negative. So we have to write tangent theta is negative 4/3. All right, now we're going to do the same problem, except we're going to do it using a triangle. So we're in quadrant 2, so that's where we're going to draw our triangle. We know that cosine theta is negative 3/5. So we need to draw our triangle so that the 3 is adjacent and the hypotenuse is 5. With our horizontal, our adjacent leg as 3, we don't know the vertical leg, and then the hypotenuse is 5. We have our missing side here, which I'll call y, and then we have this angle, which is the angle that we're going to work with, theta prime. And so first we use the Pythagorean theorem to find out what y is. So y squared is 16, so y is 4. And so if we want to find sine theta is going to be opposite over hypotenuse, so 4/5. And we know that sine is positive in the second quadrant, so that is correct. Then we're going to do tangent theta, and tangent theta is opposite over adjacent, so tangent theta is opposite, which is 4, over adjacent, which is 3, and that has to be negative because we are in the second quadrant where tangent is negative.